Last time it was OpenGL, and this time I'm going to be covering OpenGL Shaders. My name is Oscar, I'm from the Coding Universe, and this is episode 23 of Java Game Development. Let's get started. So, these shaders, these OpenGL shaders, they will form the base for more sophisticated lighting and fog systems we will create in the future. It's not compulsory that you know exactly what shaders are or how they work at the moment. This will all become clear in the future tutorials. So shaders much resemble the buffer objects from OpenGL in that you have to load them and then somehow link them to each other and then use them. So the OpenGL shading language is actually a separate programming language, a high-level programming language specifically designed in mind for creating graphics applications, for creating the cool graphics effects you see on most modern games. So here's our package for episode 23. I'm going to create a new file called shader.vert for the vertex shader. You don't actually need a specific extension of the file, but I like vert for vertex shaders and frag for fragment shaders. Damn you, mouse. Okay, another empty file called shader.frag for the fragment shader. And you're probably screaming right now, I don't know what a vertex shader or a fragment shader is, so let me explain that real briefly here for you. Okay, a vertex shader is a shader that goes over the vertex transformation. So where the vertex is in the coordinate system and where it should be on the window, sort of deal. And then the fragment shader goes over an entire fragment, so yeah, a fragment, and then what color that fragment has to have, and stuff like that. I'll explain this later in more detail again, but for now just suffice to say that a vertex shader is for vertex transformations and a fragment shader is for fragments of objects in your code. So let's now create a new Java class called ShaderDemo. And we're going to statically import, let's increase the font here a bit, org.lwjgl.openal.gl20, everything in there. So this is saying we want to use all the features of OpenGL 2.0. And therefore, the minimal version of OpenGL you have to have for this tutorial is OpenGL version 2.0. You can check what version you have by creating a main method, initializing a display, and then calling system.out.println, and we also have to statically import org.lwjgl.opengl.gl1.1, everything in there for this. So system.out.println gl get string gl version. Okay, and then it will print your OpenGL version. Okay, so let's do the basic LWJGL stuff. Let me create a new display. Let's make it 640 by 480. Set the title to Shader Demo. And then, of course, create the display. Catch the LWJGL exception, which could occur. And let's just say the display wasn't initialized correctly. Sad face. Destroy the display and exit the Java virtual machine with an error. Okay, now let's go and create the main display loop. while not display is close requested. Display.update and cap the FPS count to 60. And then down here, destroy the display. And exit the Java virtual machine peacefully. Okay, so now we have a window that does absolutely nothing. But it's still cool. Now, back to the actual OpenGL shader stuff. So we have a shader, we have two shaders, and we have a shader program. Two shaders, shader program. Now we create a program, and we create the shaders, and then we attach the shaders to the program and link the program, and then we can use the program. So a program is just a pair of shaders, vertex and fragment shaders. So I'm going to create a new integer called shader program. And let's do int shader program is GL create program. This will create a new shader program, or pair of two shaders for us. Then I'm going to create a new vertex shader and say GL create shader, GL vertex shader, shader. And do the same for another shader, which is going to be called the fragment shader. There we go. So now we have to load the contents of these files, which aren't there yet, and then load them into this. Load them into our shader program. Now let's take a step back here and go back to the shaders to write the code we need in there. And this is actually going to be really, really simple. So, as I said before, high-level programming language looks very much like C, only it doesn't feature pointers like C does. So this is going to be the vertex shader. And you can actually just not worry about what this all means here. But basically what I do here is I assign the vertex position to whatever is the best way to compute that position. And then on the fragment shader, I'll do the same, except for it will be GL frag color. Is it frag color? Let me see. Yeah, GL frag color, yes, is vec4 0.5, 1, 1, and 1. So this will assign the color of the fragment to red 0.5, full green, full blue, and just opaque. Going back to the shader demo, we can actually get around to loading the shader source of the vertex and the fragment shader. So I'm going to create two string builders. If you don't know what a string builder is, it's basically just a string, but it's a mutable version, so it doesn't require you to create a new string object every time you append another string to the string. So string builder, vertex shader source is new string builder. Do the same for fragment shaders, or the fragment shader. String builder fragment shader source is new string builder. So now I've created two string builders, one that will store the vertex shader source and one that will store the fragment shader source. Now let's create a try clause for the vertex shader. So let's load that now. Beforehand, let's just catch the IO exception that is bound to be thrown if we do something wrong with the loading. There we go. Not proper loo. What's proper loo? There we go. Okay, so now let's do buffered reader. Reader is new buffered reader, new file reader, and then the location of our shader, which is going to be source episode 23 slash shader.vert. Can't actually see the code, so there we go. Okay, and now we're going to create a string called line, which will store the line of, well, we're going to load this shader file line by line. So first it will load this line, and then it will load this line, and then this line, and so forth. So let's do a while loop, and this is a standard programming usage, I guess you could say. So line is reader.readLine. Programming practice, I meant to say. So do while line is reader.readLine. So read a line, store it in line, and then check that if it isn't null, because if it's null, that means we've reached the end of the file, and we don't have to continue loading the file. So do that. And then vertex shader source append line. There we go. Okay, and then we can close the reader. And let's check if this actually works. System.out.println, and let's just print our vertex shader source. See if it actually works. Let's hope it does. Oh yeah, forgot one thing. You actually need to have new line characters at the end of each line. So instead of doing append line, I have to append another thing, which is going to be the new line character. So now you can see what's in here is exactly the same as what's here. Now we can copy and paste this. Do the same for the fragment shader. So shader.frag fragments shader, and here as well fragment shader source. And let's just check if this works for good measure. So there we have it. We've loaded the shader source. So that's only the first step, really. Now we're going to, link this shader source. So tell OpenGL where to find the shader source, and we're going to do that by using the command GL shader source. And then we're going to specify the shader. In this case, first let's do the vertex shader. And let's do the vertex shader source. Okay. And then we can compile the shader by calling GL compile shader and then vertex shader. And now to check if this vertex shader has actually successfully compiled, we can create an if statement. So if, and then GL get shader vertex shader GL compile status, and then is GL false. So if the compilation process wasn't successful, let us know, please. Vertex shader wasn't able to be compiled correctly. Yeah, let's just do that. So let's check if the vertex shader can be compiled successfully. I hope so. Yes, it can. Do this do the same for the fragment shader. fragment shader. Fragment. There we go. And so now we've created the shaders. We've told OpenGL where to find the shader source. We've given it to OpenGL, and then we've also compiled the shaders. For good measure, let's just check if the fragment shader compiles successfully too. Yes, it does. Okay, so now that we have this, we can attach the shaders to the shader program, and we do that by calling GLAttach, and then let me see, shader program, VERTEX shader, the same for fragment shader, GLAttach, oh, it should be GLAttach shader, sorry, there we go. And then we can link the program by calling GLLink program, shader program, and lastly we can, let me see, validate the program by calling GLValidate program, shader program. Now that we have all this stuff set up, let me see, 60 minutes already, oh that's quite long. So now that we have all this stuff set up, we can actually go into the main loop and call GLUseProgram. So we can tell OpenGL we want to use this program to well, replace the fixed function pipeline, which was what was drawing the stuff before. So shaders are actually a replacement for the standard OpenGL pipeline. So you can fiddle around with it yourself. Create all the cool effects you like. So we can call GLUseProgram shader program, and then when we're done using the program, we can go back and use nothing. GLUseProgram 0. We can also just clean up on our program once we're done. So that's called GLDelete shader vertex shader and GLDelete shader fragment shader, and also GLDelete program shader program. There we go. So we're finally done with all the stuff for the shaders, the setting up, the initializing, but frankly it doesn't do anything except for drawing the shape with the color, well, a half red and then green and blue. I don't actually know what color that is, but we're going to find out soon enough. So let's draw a triangle with old crappy immediate mode drawing. Let's just use different colors too. So GL begin, GL triangles, GL color 3F, 1, 0, 0, GL vertex 3F, minus 0.5, minus 0.5, and then GL color 3F, 0, 1, 0, GL vertex, this should be 2F, 2F, 0.5 and minus 0.5, and then GL color 3F, GL cooler 3F, 0, 0, 1, and GL vertex 2F, 0, and 0.5 F, and of course GL end. So when I run this, it should display a triangle with a single color. Apparently it's cyan. So the weird thing is that we actually passed red, green and blue here, but the actual result is cyan, and that's because the shaders we created replaced the standard OpenGL functionality, as I said before. So this is actually very unpractical because I can't use the colors given to me here. And to use the colors given to me, I'm going to use a built-in OpenGL attribute called GLColor. I'm going to create a varying vec3, call it color, create it in the VERTEX shader file and fragment shader file. And what varying means is that when the shader program initiates for every vertex, this varying vec3 color isn't yet defined, but we define it, or isn't yet initialized, but we initialize it to a value in the vertex shader, and then we can use that value in the fragment shader. Because you see, the OpenGL value GLColor is only available in the vertex shader. So what we do is color is glcolor.rgb. And this might be confusing to you, so I'm going to tell you a bit about OpenGL GLSL shader types. So there is this vec3 type you saw earlier, and now this is actually a vector3 type, a type consisting of 3 components, x, y, and z, or in this case r, g, and b. Then there are also 4-dimensional vectors, which consist of x, y, z, and w, or r, g, b, and a. Now this GLColor attribute OpenGL provided us is actually a vec4, so we need to convert that into a 3-component vector by calling glcolor.rgb. And this is a technique that is called swizzling. So what we do here is we take the component r, and then the component g, and then the component b, create a new vec3, and put that in the color vec3. If I were to just say color is GLColor, then it would throw an error as seen here. Actually, it wouldn't throw an error, it just wouldn't compile. Here, vertex shader wasn't able to be compiled correctly. This should be glcolor.rgb, and then shader.frag, and now we can use glFragColor is vec4 color.1. So now we create a new vec4, and then the first 3 components are automatically filled in because we use color with this vec4, so to speak, constructor. And then the 4th component will be 1. So it will always be opaque. So those are some simple shader techniques, simple but essential shader techniques. And this is the final program. If I run this, you can see it's exactly the same as, well, if I were to do this without the shader functionality we just created with the normal OpenGL pipeline. And I can prove that by removing GLU's program. So now it just uses the standard OpenGL functionality, and it's exactly the same. So that, in a nutshell, in a pretty long 23-minute nutshell, is how you can use shaders to mess around with OpenGL. In the upcoming tutorials, I'm going to talk more about how you can use this, because this was a really brief introduction, and you're probably clueless as to what applications shaders would actually have. But as I said before, this will be in upcoming tutorials. Now, I'll see you in the next tutorial. Bye.